Here we have some strong acids which ionize 100% in solution. HClO4 is perchloric acid, HCl is hydrochloric acid, HBr is hydrobromic acid, HI is hydroiodic acid, H2SO4 is sulfuric acid, and HNO3 is nitric acid. So let's do a calculation using nitric acid here. So calculate the pH of a 0.030 molar solution of nitric acid. Well, nitric acid is a strong acid, which means it ionizes 100% in solution. So if we have HNO3 and H2O here, the nitric acid is going to donate a proton to water, and if water accepts a proton, water turns into H3O+, the hydronium ion. If HNO3 loses a proton, we're left with NO3-, or nitrate. Since nitric acid is strong, we get 100% ionization here, and everything turns into our products. And so if this is our concentration of HNO3, this would also be our concentration of hydronium ions. So the concentration of hydronium ions is 0.030 molar since we're dealing with a strong acid. So to calculate the pH, all we have to do is plug in to our definition of pH. The pH is equal to the negative log of the concentration of hydronium ions. So all we have to do is plug this number into here. So the pH is equal to the negative log of 0.030. So let's get out the calculator and do that. All right, so we have the negative log of 0.030. So we get 1.52. So remember, when we're rounding, right? So the pH is equal to 1.52. So for our significant figures, we have two significant figures here. So we have 2 to the right of our decimal point. So instead of writing it this way, right? So instead of writing this, you could have written a shortened version. You could have just written HNO3, nitric acid, ionizes 100%, and so it turns into H+, and NO3-. So that's just a shortened version of the same thing we have above. And so if you're working with this, you could have said that the pH is equal to the negative log of the concentration of H+. And so that's the same thing as we did above. All right, next let's look at strong bases. So we're only going to talk about metal hydroxides as being strong bases in this video. So some common metal hydroxides: sodium hydroxide, potassium hydroxide, calcium hydroxide, and magnesium hydroxide. So let's do this problem. Calculate the pH of a 0.20 molar solution of sodium hydroxide. So let's go ahead and write sodium hydroxide here as a strong base. You get 100% dissociation in water. So 100% dissociation. Sodium hydroxide consists of Na plus and OH minus. So you get dissociation and you get the sodium cation and the hydroxide anion. So Na plus and OH minus in water. So if we have 0.2 molar of NaOH, we're also going to get 0.20 molar of hydroxide ions in solution, since sodium hydroxide is a strong base and we have 100% dissociation. So if the concentration of hydroxide ions is 0.2, right, we need to go for the pH. And so one way to solve this problem is to use this equation. So the concentration of hydronium times the concentration of hydroxide is equal to 1.0 times 10 to the negative 14 from an earlier video. So we can plug in our concentration for hydroxide, and we can say the concentration of hydronium is X. So we have X times 0.20 is equal to 1.0 times 10 to the negative 14. And so if you do that math, right? So if you do that math, X is equal to the concentration of hydronium ions, and this would be 5, right? This would be 5.0 times 10 to the negative 14. So now that we have the concentration of hydronium ions, we can now calculate the pH of our solution, because pH is equal to negative log of the concentration of hydronium. So we can do this on our calculator here. So let's get out the calculator to find the pH. So the pH is equal to the negative log of, this is 5.0 times 10 to the negative 14. And so we get a pH of 13.30, right? So let's go ahead and write that down here. pH is equal to 13.30. So there's another way to do this problem, right? And that is when you find, let me use a different color for this, when you find the concentration of hydroxide, you can immediately find the pOH, right? So the pOH is equal to the negative log of the concentration of hydroxide ions, right? So that would be 0.2. So we could plug that into here to find the pOH. So pOH is equal to the negative log of the concentration of our hydroxide anions. So let's go ahead and do that math. Right, so we have the negative log of 0.2, and we get 0.70. Right, so the pOH is equal to 0.70 here. 0.70. And to find the pH, all we have to do is remember another formula, right? pH plus pOH is equal to 14. So if we plug in the pOH as 0.7 right here, 14 minus 0.7 obviously is going to give you 13.3. So we get the same answer for the pH no matter how we do this problem. All right, let's do one more calculation here. So let's look at what we're given for our problem. Calculate the pH of an aqueous solution that contains 0.11 grams of calcium hydroxide in a total volume of 250 milliliters. Right? So if we have calcium hydroxide, right, if we're going to have an aqueous solution of calcium hydroxide, let's look at what we're going to get here. We're going to get calcium ions in solution, right? And we're also going to get hydroxide anions in solution. But if you balance this, right, you need 2. You need a 2 here. So for every 1 mole of calcium hydroxide dissolved in water, you're going to get 2 moles of hydroxide ions. So let's first figure out how many moles of calcium hydroxide we have. So over here we have 0.11 grams of calcium hydroxide. So let me write that down here. So 0.11 grams of calcium hydroxide. One way to think about finding the moles is to divide by the molar mass. So the molar mass of calcium hydroxide is 74 grams per mole. So if we divide 0.11 grams by 74 grams per mole, the grams would cancel, and we would get moles here. So let's do that on the calculator. So 0.11 divided by 74 is equal to 0.0015. Right? So we get 0.0015 here. So 0.0015 is how many moles, that's how many moles of calcium hydroxide. So let me emphasize this here. This would be the, right, if we have this many moles of calcium hydroxide, how many moles of hydroxide ions would we have in solution? Right? We would have twice that number because we have this ratio here of 1 to 2. So we need to multiply that number by 2, right? So by 2 to figure out how many moles of hydroxide ions we have. So that number times 2 would be 0.0030 moles. And now we're talking about moles of hydroxide ions, right? Over here we're talking about moles of calcium hydroxide, and here we have moles of hydroxide. All right, so let's figure out the concentration of hydroxide ions in our solution. And concentration, right? Concentration would be moles over liters, right? Liters of solution here. So our total volume is 250 milliliters. So we convert 250 milliliters into liters, right? And that would just be 1, 2, 3, so 0.25 liters. So 0.0030 divided by 0.250 liters, that's going to give us the concentration of hydroxide ions, right? So this gives us concentration of hydroxide. And let's do that calculation here. So let's get some room. So we have 0.0030 divided by 0.250, and we get 0.012 molar. Right, so this is 0.012 molar for the concentration of hydroxide. Now that you have the concentration of hydroxide ions in solution, you can find the pH using one of the two ways that we talked about above. Right, so you could go for this equation. Hydronium ion concentration times hydroxide ion concentration is equal to 1.0 times 10 to the negative 14. All right, and you could take this and plug it into here. So you get X times 0.012 is equal to 1.0 times 10 to the negative 14. And let's get a little bit more room here. And let's do this calculation really quickly. So we have 1.0 times 10 to the negative 14. We're going to divide that by 0.0. Actually, let me do that again. We're going to divide that by 0.012. And this is going to give us 8.3 times 10 to the negative 13. All right, so let's write this down. X is equal to 8.3 times 10 to the negative 13. And remember what X referred to. X referred to the concentration of hydronium ions. So this is the concentration of hydronium ions, which means we can now calculate the pH. Right? The pH would be equal to the negative log of that concentration. So the negative log of 8.3 times 10 to the negative 13. So let's do one more final calculation here. So we're going to do negative log of 8.3 times 10 to the negative 13, and we're going to get 12.08. Right, so the pH is equal to 12.08, and we're finally done. We're finally done with our problem here. So notice the pH is in the base range. So calcium hydroxide is a base.